Yes, Sharon, are you going to tell me you didn't bring your paper? Okay. Guys, switch to your answers, guys. I mean, your work from last week are the ABCs. We're going to go through it real quick. Then after that, we're going to move on to the next annoying part. Which is the preparation of soluble and insoluble salt. Huh? What?
The lens experiment doesn't meet up with.
No.
It's not coming out for like our chemistry this kind of thing.
I don't know. Alright, guys. Starting off with the first question.
From which page?
Don't know.
Like the first question. Because
Yes.
we discussed the first 5 questions.
Huh? Oh, we didn't.
We did. Remember? And
What's your answer for question number 1? Shit, let me record first. Oh, it's recording already. What's the answer for question number 1? Boy is correct because I want to use a weak alkali to neutralize a weak acid. Question number 2. You. What's your answer for question number 2? A, correct. A. I don't even remember the question. Hey guys, stop me if you did not get the question correct, guys. And now I'll read through it again. But let's just assume that everyone is correct. Because the questions here are relatively easy. Question number 2 is A. Question number 3, what do you get? Boy is correct. Question number 4, what do you get? Donkey is correct. Question number 5, what did you get? Boy is correct. First 5 questions, anyone got anything wrong or not? Want to discuss? Question number 2 and question number 3.
number 5 is what? Yeah.
Boy.
Number 5 is. Teacher?
Yes.
Well.
Okay, starting with question number 2. What is this here? Hydrochloric acid is often used to clean metals by reacting them with a surface coating, which develops on some metals when exposed to the atmosphere. Which role describes the surface coating on these metals? Guys, first and foremost, whenever we talk about this surface coating of metals, we use aluminium for an example. Do you know why aluminium is non-reactive by nature? It's because aluminium by nature actually forms a natural layer of oxide, which is actually non-reactive by nature. Right, so the first thing is whenever we talk about coating of metals, right, it will always be an oxide layer. Okay, it will be an oxide layer. But in this case here, they ask us to clean the metals, right, using hydrochloric acid. Hydrochloric acid by nature is acidic by nature, right? So in order for me to clean it, means to say I'm cleaning up an alkali base, right? So first and foremost, it will definitely be oxide because metal oxides are generally alkali in nature, right? And whether it's basic or acidic, it will definitely be basic because metal oxides in general are going to be basic or acidic. Basic or acidic metal oxides. What the hell? Were you here last week?
Yeah.
Metal oxides are always going to be basic. Okay, and because it's a basic oxide, it must react with an acid. What was your answer, by the way? B. Oh, metal oxides are generally basic in nature. Metal oxides are generally basic in nature. Remember this. In fact, I've told you, right? Like, for example, sulfur dioxide is acidic in nature, because it's non-metal, right? Non-metal oxides are generally acidic by nature. Right, same like carbon dioxide and whatnot. Okay. Who said question 3? Who was it? Question 3? Oh. Calcium reacts with sulfuric acid to form a salt, calcium sulfate, and another product. This is a metal, right? This is an acid, right? What's the thing that reacts with metal and acid again? I told you there's one word that we can remember, right? What's that word called again? Huh? Mash. Very good. What does mash state?
Metallic
Metal and
acid.
will form.
Salt and hydrogen.
So what was your answer? Water.
Yes.
Water is for alkali and acids. Only neutralization will form water. Anyone else say any question just now? Okay, I will remember this. You actually need to remember this because this actually comes out in your exam very, very often. Mash, metal, acid, salt, alcohol, salt, hydrogen. Okay. Huh? Yes. Let's proceed with the next 5 questions because the next chapter is very annoying. Next 5 questions. Where did I stop? You, question number 1. Hey, you did already, right? You, question number 1. B is wrong. Answer is C. We'll come back to this.
Then A.
Yeah, oh, sorry, I made a mistake. It's actually A, even though I said C. You, what's your answer for question number 2?
B.
Sorry?
B.
Donkey is correct.
He said B. Okay. What?
Which of the following...
Sorry. Oh shit.
You, question number 3, what's your answer? C, wrong. Answer is supposed to be A. We'll come back to this also.
No, you figure it upside down.
What?
It's question 2 and 4 and 3.
Yeah.
What? Wait, what? Say that again.
Question 2.
Did you look at for question 3, my answer is A.
What the hell?
Actually.
Okay, then, okay. This question, the one where it's not, I will go through this later anyways. This one with the non-indicative A's was supposed to be A, and then this question number 4 was C is correct. Okay. Then question number 5, what's your answer? Hey, boy, And then question number 6, what's your answer?
D.
Donkey, good. Question number 7, what's your answer? A, good. Okay, out of the 7 questions, anyone got anything want to ask or not? Question number 6. A student gradually adds excess potassium hydroxide. Potassium hydroxide, acidic or alkali? It's alkali by nature, right? From a burette to a conical flask containing sulfuric acid as part of the rate of investigation. Which statement describes the pH of the sulfuric acid as aqueous potassium hydroxide is added? What was your answer? pH increases until neutral, but I keep adding more. Even so right now it starts off with sulfuric acid, right? Which is supposed to be a strong acid, So the pH is damn low, right? Anywhere from 0 to 3, let's just say, right? I don't know what's the exact number, but in this case here, it's given as 1. Okay. Then as I keep adding potassium hydroxide, which is alkali, the pH value starts increasing, right? Because it will reach neutrality at some point, right? It neutralizes. Then, but after it neutralizes, I didn't stop, because the keyword here is added in excess. Means to say, even after it neutralizes, I continue adding this alkali solution. That's why it rises all the way until the pH value is at the alkali range, right? You get what I mean? You also answered C. Wrong.
Then question number 1.
Wait, let's do question 1 first. A student is provided with an unmarked beaker containing a colorless solution and asked to identify it. The student decides to perform a series of reactions with the solution and record The observation. Which of the observation is not indicative? Okay, for this one here, addition of ammonium carbonate and a colorless pungent gas is produced. What do you think this pungent gas is? No, it's actually ammonia. It's going to be NH3. This ammonia itself is a base by nature. So this is not an indicative observation of acid. Yeah, you're going to see this word a lot, by the way, guys. Whenever you see the word pungent gas, right, and especially if it's colorless, I want you all to remember that it's going to be ammonia gas, which is actually damn smelly. And like sometimes I used to back then when I was in primary school, right?
You used to throw people.
Yeah, I used to go to primary school toilet damn smelly, right? Especially the boys' toilet. For girls, maybe you cannot relate lah. The toilets are damn smelly because literally all the assholes are peeing everywhere, right? So what they did was right, they shut up lah. Then after they actually placed this toilet cleaner, which I didn't know what it was. But every time you spray that shit, right, you can actually smell the pungence. It's damn bad one. And now, as I grow older, I realize that is damn strong ammonia liquid, which is used to, clean up all the shit from the toilet. It's a very strong pungent smell. You definitely, once you smell it, right, you won't forget it. It's a very annoying smell.
How about you bring it?
But anyways, go buy it yourself. Anyways, whenever you see this word pungent gas, you need to know that it's going to be ammonia. It's quite popular in your exam. It's quite commonly asked in your exam as
Is this the
well.
only pungent gas, or is there other?
The most popular one. I'll have to see the question out, but whenever I see this word pungent gas, straight away I think about ammonia. Okay. Yes, you said question 5.
Yeah.
A student is testing two substances P and Q as shown. The results of the test of a universal indicator turns blue. So first and foremost, if it turns blue, it's going to be it'll be alkali in nature, right? What are the substances P and Q? So these two substances, when they combine together, they're going to form an alkali substance here, right? And once again, if I look at the answer here, what kind of alkali gas will actually be produced here?
Sodium nitrate and
Ammonia hydroxide. It's actually going to be ammonia though. Ammonia hydroxide. Why NH3OH? Okay, I wanna emphasize this because I actually see this a little bit in your exam as well. You see, whenever there's ammonia is NH3, right? Right. I tell you, every time I see this NH4, right? Usually what's gonna happen is right. First and foremost, the product will usually be ammonia, right? And the extra one hydrogen, do you know what happens to it? It will actually combine with the OH in the yes, and it will form water. This is also a common trend. It's something that you have to learn through experience, but I see this common trend very often in the exams. You need to be especially alert when you see the word NH4 here, because every time when there's one extra hydrogen, right, it will usually combine with the OH to form water, and then the rest of it will be the third product, which in this case here will be sodium nitrate. You get what I mean? So this ammonia is the one that turns the litmus paper blue. In this case here, it's the universal indicator. But blue usually is a good indicator that it's going to be alkali by nature. Okay. Yes. Any other questions, guys? Yes. Anyone? If not, we move on. Where did I stop just now? Who did I stop just now? Did it? You again. What's your question number 1? What's your question number 1? Hey, I feel like we did this question with you that day. What's your question number one? Huh? Donkey, good. Second question. Good. Third question.
What is the good place?
Oh, why not? Take a wild guess right now.
Okay.
Good. Question number four. Take a wild guess right now.
Let's go with C.
C.
You know, they always say when in doubt, always say C.
What's wrong with C? What do you think's wrong with C? This is an alkali, this is a metal, sorry, this is a acid, right? Isn't this a salt and this is water? What's wrong with this?
Those answers.
Hey, take a wild guess, hurry up. A, B, C, D. D, wrong. It's supposed to be B. We'll discuss this later. You, what's your answer for number five? You. Sitan, you. What's your answer? C, good. Incorrect. Okay, let's talk about this question first. First and foremost, right? This is a carbonate, right? This is an acid, right? Carbonates will form three things. What are the three things? Refer to your notes and tell me. Salt, water, and carbon dioxide, right? The most distinctive one is always carbon dioxide. I told you from the CO3, it will split into CO2, right? But then right now, the only missing component is the water, right? It's not supposed to produce hydrogen gas. So it's very important that you know. Actually, most of the time you don't need to know what most of these salts are. In fact, I don't know most of these salts are. But the trend is the important one, guys. You need to know that if the carbonates react with acid, there will be a salt, there will be water, there will be carbon dioxide. And from here, I don't even care whatever this thing is, what it's used for, I don't care about it. I just look at the trend What's wrong with this? Okay, correct. For those who say this is another trend, right? I don't care what alkali is it. I don't care what acid is. The only thing I want to know is whether I can identify it's going to be a base and this is going to be an acid, right? Base acid always be salt and water, right? Boss, remember BAWS, right? Remember or not? Base, acid, water, and salt, right? So it's always about the trend. You may try right, to memorize all the salts and all the combination, blah, blah, blah. I don't do that. You can, but it's better that you identify the trend. It's easier for you to attempt the questions that way. Yes, any other questions from the next five? Huh? Three? Two? Wait, question two. In a reaction rate experiment, a student investigated. Hey, did I tell you not to do that just now? Give me that. Give it to me now. Pass it to me. I try to treat you all like, decent human beings, right? But you always force me to treat you guys the children that you all are. Is this what you want me to do to you guys? To treat you guys like children? Huh? Don't you think I give you guys the relative enough freedom for you to do your own thing? And you make me resort back to this. Hey, everyone pay attention. In the rate of reaction, the student uses equal volume of acid P and Q to react with excess magnesium. once again, this is going to be a metal and this is going to be acid, right? So roughly, I think lah, it's going to be somewhere around here. It's going to be somewhere around this, but let's just continue with the question. Following observations were recorded acid P produces hydrogen gas faster than Q, okay, which makes sense. Both gases produces the same total volume of hydrogen gas. Okay. And after that, which statement correctly explains the student's observation? Well, who asked this question? Huh? What was your answer? Huh? Okay, so if you look at this first part here, this is a relatively important hint, right? Because with this part here, I know for a fact that they actually one is weaker than the other, right? Because one has a faster rate of reaction, right? So since P was faster than Q, then I would assume that P was the stronger acid, right? Which is in line with this. You probably may be confused with this part here, right? But because they produce the same total volume of hydrogen gas, it means to say, right, the amount of H plus ions was going to be the same inside. That's why they won't have more concentration. In fact, if anything, they'll have the same concentration. You get what I mean? So from here, you should know that it's going to be weaker based off this part here. Yes. Yeah.
So you can say question 1, 2, 3.
Good. Question number 1. Eugene, please answer me. Why is the answer donkey? What's happening here? Take a wild guess now. I'll correct you. Why is number 1 a base and number 2 an acid? Huh? The product. Okay, explain a little bit more.
You said a wild guess, my guess.
Can it be a little bit more elaborated, the wild guess? Let's start with the acid one first. Why was number 2 an acid? Because it gives off what?
Hydrogen.
It's the hydrogen ion, right? So first and foremost, I know that based on this, because of this thing here, I know it's definitely going to be between acids. 2 is going to definitely be an acid, right? Because it dissociates H plus ions, right? Which I've constantly said for the past week that H plus is going to be acid, right? Now, how come this was the base? What happened?
Just naturally.
How come?
Because it takes.
Yeah, because the acid was reacting with the base for it to combine together. Makes sense or not? No, hydrogen is the acid. This will be the base. That's why this was the base for X. You get what I mean?
What is two acid?
Huh?
What is two acid?
Because it dissociates H plus ions, which is a common characteristics for acids. It like gives off H plus ions. Yes, ladies and gentlemen. Anyone else with any questions? Please, I hope so. Okay, this next part here. Look at all these words. Look at all these words that we have to remember. Huh? What do you mean? No way, right? I printed everything, right?
Oh no.
Okay, anyways.
Isn't this like the solution preparation?
Yeah, this is the preparation of salt. Okay. Okay, guys, listen up. Once again, you'll notice that there's going to be metallic and non-metallic oxides. I said that metallic oxides will usually behave like, and non-metal oxides will be good, safe by your friends. Right, so you can see there are many examples of oxide. Magnesium oxide, zinc oxide, potassium oxide, carbon dioxide, sulfur dioxide, and hydrogen oxide. No lah, H2O lah, water lah. Right. Metallic oxides are compounds of one metallic element with another oxygen atom. These are obviously called the metallic oxide. Everyone knows this by now. Keyword here, guys, acidic oxides are usually non-metal elements, whereas basic oxides are usually the metal elements. As you can see here, this table shows you an example of whether it is going to be a basic oxide or it's going to be an acidic oxide. But there are exclusions, like for example, these called metalloids. A common example of silicon dioxide is basically sand, right? It will not behave like an acid nor a base, guys. So there are exclusions, right? But everything here, as long as they are metals, even if they are transition metals, they will usually behave like a base. And everything here that are usually non-metal, they will usually behave acidic, except for a few exceptions. You will actually
Why is it that it goes 1, 2, 5, 6, 7, 0?
Ah.
Shouldn't be
ignore. You should be. Maybe it's just a different representation from a different syllabus or whatnot. I don't know. But for all I know, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay. But anyways, there are exceptions. Not all non-metals are going to be acidic. For example, this part here is extremely important. And in fact, they will usually, not usually, occasionally they'll test you. They'll say something like, oh, is this oxide acidic or is this oxide basic? Your answer is neither. It could be neutral, guys. And these three are commonly there. Carbon monoxide, nitrogen oxide, and this one, I can't remember what's it called already. Nitrogen, what's this N2O? Nitrous oxide. Yeah. These are neutral, guys. Keyword, you might want to write this down. It's not always non-metal oxides for sure acidic. There are exceptions here, guys. So you might want to put a little star below these three things here. Yes. Okay, but in general, most of it will follow the acidic or basic rule, right? For example, carbon dioxide, sulfur dioxide, nitrogen dioxide, and silicon dioxide here will be acidic. Silicon dioxide, isn't it sand? Is this an error? What the hell? Why did I put this here? Skip this for a while. From what I know, sand should not be acidic. If not, it will basically burn your skin off when you go to the beach. Why did I put this here? Why? Double confirm this later, but skip this. Is from what I know, not supposed to be acidic. Never really thought about it why, but it just doesn't react with acid or base. That's why it's neutral. Anyways, moving on. Basically all the basic oxides are the metal oxides, as you can see here, copper oxide or even calcium oxide here. They are generally basic in nature, right? And because of their acidity, they will be of a lower pH, which everyone knows by now. And because of their alkaline nature, they'll have a higher pH, guys, which I assume everyone knows by now. This is not the important part. I would say that this whole page here, probably this thing is the most important. Everything else, I assume you guys know already, right? This part is important though. You're going to be introduced to something known as amphoteric oxides. Amphoteric oxides the key word here is that they can behave like an acid or a base depending on the situation. Okay, a common example of amphoteric oxide that you'll always see in your exam is going to be this here, aluminium oxide, which has a formula of Al2O3. Okay, this comes out all the time. they'll ask you, define what element. I can't remember what they say lah. I can't remember, but you need to know that this is going to be an amphoteric oxide. And how do I know whether it's going to be an amphoteric oxide? I can test this by placing the aluminum oxide in acid, see if there's a reaction, and I can place the aluminum oxide in base and see if there's a reaction or not. Both scenarios will have a reaction indicating that this aluminum oxide can behave like a base. If I add acid to it, it can also behave like a acid if I add base to it, right? If I add alkali solutions to it. It has two characteristics. This is important. And zinc oxide also. But usually I see in your exam aluminum oxide. But who knows, maybe this year you guys will be the lucky one. Maybe you want to put two of them. Make sure you know. Okay. And the way, again, the way to test it is by placing it in acids and base. Yes. And of course, because you have acids and base combining together, this is known as neutralization, which will produce water once again. Okay, important. Need to know this. Yeah. Now it goes to the annoying part. You see all this, steps. You actually need to remember everything. But it's quite standardized. There's a pattern to it. Let's go through the first one first. Okay, so first and foremost, if we want to prepare salts, right? A salt is a compound that is formed when hydrogen atoms of an acid is replaced by the metal. What does that mean? For example, you see HCl, right? Replaced with potassium ion, and it will form a potassium chloride. Right, it will form a, for example, metal and acid. This thing will be replaced by this thing. Yes, replace or displacement. And usually the metal that forms with the non-hydrogen ion, in this case here sulfur, sulfate, right, will form zinc sulfate, right, and also hydrogen, which is once again the understanding of MASH, right, metal, acid, salt, and hydrogen. Okay, this statement here, it's, you understand this statement, right? You just replace the hydrogen with the metal, right? Yeah, all these are just examples. Okay, let's look at the first example. The first example of how we prepare a soluble salt. Okay, so in this scenario here, we're basically adding zinc to what's called the sulfuric acid, right? And first and foremost, guys, in order for you to prepare these kind of zinc sulfates, we have to keep adding the zinc into the sulfuric acid, which you will realize that there's going to be hydrogen forming, right? There's going to be hydrogen forming. The acid is used up when the bubbling stops. This part here is also quite important. In your exam, for some reason, they love to ask, how do I know that all the acid is used up? You need to mention that when you see no more bubbles form, in other words, there's no more hydrogen form already. Okay, so you'll always keep adding the metal in excess all the way until you see there's no reaction forming. And when there's no reaction forming, it's because there is no more bubbles. No more bubbles. Okay. So once you see that the acid doesn't produce any bubbles anymore, what you're going to do is you're going to start by removing the excess zinc. How do I remove the excess zinc? By pouring everything into the filter paper. Right. Remove by filtering. Once you remove all that, right, you'll have unreacted zinc here, which is something I don't want. Right. Then this is the part where I want, because the soluble salt is inside this aqueous solution here. Okay. Then aqueous solution of zinc sulfate is left. Once I have this, right, because it's aqueous, which means to say there's water inside as well, right? I don't want the water. I only want the salt inside the solution. So in order for me to remove the water from the solution, I have to heat the solution to evaporate the water. Okay, once all the water leaves, this helps us obtain a saturated solution. You're going to see this word a lot. Saturated means to say concentrated. Right, like for example, if you have water and Milo, right, you keep pouring Milo into the water, eventually they'll reach a point where saturation occurs, right? Which means to say, even though you keep pouring powder in, the Milo won't dissolve anymore. This is what we call saturation, basically concentrated, right? Once you have a saturated solution already where all the water has left, you leave it to cool and it will crystallize. Eventually, when it crystallizes, that crystal will form zinc sulfate, which is the soluble salt we wanted. Hui. Yes. Oh, please don't use the washroom. They are fixing the toilet downstairs. If you have to use the washroom, you have to go down to Showroom Station. Guys, I noticed that quite a few of you guys are falling asleep. I know this is a bit boring, lah. Yes.
It's a big thing for things.
Zinc from zinc sulfate, I'm sure you can, but it will be a totally different process, which I don't remember. Electrolysis, yeah. I think you can, but I don't remember how. Anyways, it's not in your syllabus, They won't ask, Yes. Go for it, my friends. Hey, guys. This part is extremely important, You actually, I've already tried my best to summarize everything into picture format so that you can roughly remember. But seems like some of you guys are falling asleep. So can I get you all to start reading everything until this page? Hey everyone, I'm going to give you 15 minutes. Can you read through everything until this page and we'll discuss whatever you don't understand, which I assume only some of you guys will actually read. But don't worry, I'll ask you questions later. It's quite straightforward and easily understandable. I want you guys to start reading from here, preparing the soluble salts all the way until you see this this solubility rule here. Stop here. I have to explain a little bit here later. Start reading right now, everyone. Don't worry, guys. I'm going to ask you guys some questions later. I'm reading now. Why do you do that? Wow, such young age already got insomnia already. That's GG, bro.
So sleep without sleep. So this kind of influence when you because she can't reply my mom.
No. Read the last question.
Yeah, yeah, you go to equal.
No.
Why not? No.
I hate my family. I even like past 2 weeks ago. I went there because of my grandfather's birthday.
And you're not celebrating as well birthday.
I went early. Hey, can you all read first? Say, your special case did not read credit. Should I text your dad and say that you already graduated?
That would happen for you.
Everyone.
This is part. Horrendous behavior.
Sarah, time to wake up.
And probably one of the like.
We're reading.
Discrimination. Then the equality.
Hydration is a neutralization of acid to base.
And why?
Base. Or base to acid. You see how when it's turning color, right, it's an indication that it's turning to alkali.
Like how they know when to stop?
Sorry, once it goes from pink to colorless.
Is it like when it's big and
Goes
it's
from
at like
pink to colorless, indicating that it's going to be it's tilting towards the alkali.
how do you know like how like let's see. It's like it's colorless, right? Once you add, if you add too much, it will look
pink.
but
It's pink.
you add that with if you add too much, if excess, it will still be colorless. How do you know whether your thing is
That's why you have to drop it. Hydration is like take visually one drop at a time.
so if you like just suddenly from colors?
You're gonna use soil one. Wait a minute, have you done this before?
No, not like this, man.
Really?
I don't know the definition.
Okay. I show you a video on hydration. It's very interesting.
But I see on TikTok then once it turns like you start jumping I don't know the first. Then they say, oh, wait.
Only jumping now, but usually as because you drop the alkali solution one drop at a time, so you keep dropping, right? Then as soon as it changes color, right? That's an indication that it's tilting towards the alkali.
So you can stop, yeah.
And then you stop. Then once you must be very accurate so that you know the size. That's why you can't like drop, drop. The change color, no, drop, the change color, no, drop, the change color. Drop one more drop, right? Then one extra drop, change color, right? You have to stop it already. That's the tilting point already. Then you have to record down how much alkali was used. Then you have to do it again without the opposite. Because the opposite is that make the whole solution zero. And the ratio will be wrong.
Oh, yeah, what the oh yeah. Oh, I know this good. You should
Actually use the oil.
but imagine there are a lot of bounce here.
Oh.
Can you pick up my phone first?
Oh.
Can you bring my phone to the toilet? My camera's off. I think all see your noise pan in one thing.
Why? This camera.
You know I can connect phone, right? Yeah, I see.
I can actually control my camera
and
from.
see what the screen is seeing.
I hope they have X-ray too then. Guys, 10 more minutes, read everything. And then after that,
How are we gonna go to? I think I'll go down and say I want your fitness. We actually went to the code for exhibition.
Hey, you open the door and close or not?
Over Spider-Man. Yeah,
Actually,
yeah.
like
You can bring the phone right. Bring it up. Like he's taking a place and comes. There's like jumping. Okay.
hey, so
Listen, no, because it's about the other side shot.
I didn't know it first. You know the doctor was so for like a chemo is yes, yes, yes. Oh, see,
This is qualified in the world. The one correct is too far away.
Oh.
Oh. Is that getting closer stuff?是啊，我之前有个这种投资，我有尝试了，有一个事情，对那个我感到是错的。Yeah, I saw you pissing my head.
Is it?
Or
Oh,
solid. I actually could, but when you walk, you can't, right? Suddenly disconnected. It was actually good.
Do you neutralize the water in the what is it called? Oh shit, what is it called? I don't know what it's called. The maton.
Yes. Yes, I produce more water there.
Your ammonia displays the H from the.
Wait, did the guy look at you like, what is this guy here? That's why you just go to the toilet.
No, I didn't even bother looking at him. Just walk straight. Yes. Jaren, how can I help you? Which question you want to ask?
And this one, they say it heats the solution level with the water, right? But why do they need the cooling and the evaporating basically when they're already heated up?
Oh, because once you heat it, it's not fully done. And you heat it until crystallization. Then after you have to wait. There'll still be some water in there.
So you
You're not
use
like burning it, you're
We
not
use
boiling it.
the basin to let
Yeah. Evaporation basin is just like a small little cup thing, by the way. It's not really a basin.
to use, and then they filter out the rest of the water that's not gone from the.
You let it naturally evaporate. Why the hell is your phone getting so damn hot? Oh, fuck.
I don't know.
Stupid guy. So I assume you're done reading everything? Can I ask you questions or not? Yeah.
Use the there's a look at what's this one? Yeah.
Oh, someone's messaging me. Oh, damn. Sarah, I just saw your message.
Oh, you're horrendous. You're evil. You're horrible. You're wicked.
Let me send it to you right now.
Unbelievable.
Sarah, Korean GTG. Guess your name, Sarah. Indong never reply her. He said he didn't receive your text.
Oh shit, she did.
Oh shit.
It's my bad, Sarah.
Why is there no sound coming out here? Weird. Has anyone been talking to me and I've not been replying them?
What's that?
Gentlemen, I assume you're done reading. Can I ask you guys questions or not? On what?
What does?
Okay, guys. Everyone pay attention, okay? I'm going to go through this real quick, okay? So if you look here, right? If you want to prepare a soluble salt, guys, with an insoluble base, every method is going to be different, but actually you can see the pattern is almost similar one. It all revolves around having a solution, having the solid mixed together. Then after you're going to filter it, and it always involves some kind of heating or evaporation inside one. Okay, you'll notice that the steps are somewhat similar. The only thing I do want to highlight about is basically this one here, which is the titration process. Okay, who here never done titration before? Good, it's YouTube time. Bye bye. What? Please pay attention, everyone. It's very important.
Concentration of solution when you go to the concentration of another solution. You carefully add no solution to the same volume of the unknown solution until the reaction is complete.
What the hell?
This enables you to work out the
What?
concentration of unknown solution. You may need to use the indicator to signal the end of the reaction.
Wait,
I feel like the passenger. Just think so.
Sure. What? Subtitles so everyone can read properly as well. What? Why is he here right now?
A titration is a technique used to work out the concentration of an unknown solution when you know the concentration of another solution.
Usually
You
acid and
carefully
base are
add
the
the known
solution.
solution to a set volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use the indicator to signal the end of the reaction. You can calculate the concentration of an acid or an alkali by carrying out a titration experiment. In this video, we're going to look at how to carry out titrations. In the next video, we will then look at the calculations to go with the experiment. The apparatus needed for titrations looks like this. The pipette is needed to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to 0.05 cubic centimeters accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with a known solution. 4. Record the starting volume on the burette. 5. Slowly add the solution from the burette to the unknown solution in the conical flask. You may need to swirl the flask to mix, or use a stir plate. 7. Stop adding when the reaction is complete. The endpoint is reached. This is where an indicator may help because there would be an appropriate color change.
This video is Shit, huh? You guys understand what he's talking about? You guys know what this? Ah, look at you guys know what's going on for those. This video is shit. I don't know what the hell he's talking about. If I put myself in your shoes, I don't know what's going on really.
The bread tube is so what is this?
Okay, look, I think so you see, it's actually dropped by the droplets one, you know. Every time this I will assume is the alkali and this is going to be the acid lah. What's the color again now?
What?
What's the color for phenolphthalein again now? It's colorless and pink one. Which one was it?
Colorless acid. Thing is base.
Confirm, right?
No.
Okay, so let's say for example this will be the acid which is colorless. It already has the phenolphthalein inside already and this is going to be the alkali which is constantly dropping inwards. As soon as it drop inwards, right, it will turn pink for a while. It will turn pink for a while because the universal indicator reads that it's going to be an alkali solution here. But as soon as you swirl it, right, this pink will disappear straight away. Watch. Why the hell is it in slow motion? Shit lah, this one also. Wait, I have to find one that's good. There must be one that's good, right? It's to
What is that?
What?
Yeah, down.
This one?
Yeah.
Okay, we'll judge, okay, after 3 minutes of watching.
So see, they go.
What is a titration? A titration is a technique where a solution of a known concentration is used to determine
Okay, pay attention, please. Maybe this will be good. It's better this time.
the unknown concentration of a solution. Usually, the solution of known concentration or titrant is added from a burette to a known quantity of the analyte, the unknown solution, until the reaction is complete, which is indicated by the endpoint. The accuracy of the results of your titration will be a reflection of the care you took while performing it. When done carefully, titrations give very accurate, precise results. Here is a step-by-step procedure required for performing successful titrations. The burette has now been cleaned and prepared as shown in the previous videos. The meniscus is level with any graduation mark on the burette between 0 and 2 milliliters. The initial reading will be recorded, remembering to do it to 2 decimal places. The analyte solution is pipetted into the conical flask and then a few drops of the indicator is added. The conical flask is then placed under the burette. When performing the first titration, the solution is delivered at a rapid pace to get a rough idea what volume is needed to reach the endpoint. This is known as a rough titration, and it is not included in your final results as it is not accurate. However, you still need to record the final volume reading from the burette.
Okay, I want to explain a little bit for the rough titration. You see, right? By right titration, you actually drop the alkali solution by drops on. But because there's 50 ml, right? You don't know you're going to drop how long before you reach the rough amount needed for the alkali to neutralize the acid. So what they do here is they do a rough titration first. They'll literally switch on the valve and the alkali solution, right, will flow down like a stream one, you know. And this guy, he will constantly swirl the thing because as long as it's not turning into alkali, right, it will still be colorless one. So it will keep going colors until a certain rough point where they say it's about 24.5 ml worth of alkali is needed to neutralize or change the acid into the alkali side. Okay, with this one here,
The volume of solution delivered is determined by subtracting the final reading with the initial reading. The burette will then be refilled. Initial readings recorded in the solution in the conical flasks prepared in preparation for the next titration. The next titration will be done carefully to ensure that the endpoint is not missed using the volume recorded during the rough titration. The general procedure is to deliver approximately 3/4 of the volume of titrant recorded from the rough titration at a rapid pace and then add the titrant slowly until the endpoint. It is even possible to add a drop, swirl, add another drop, and so on until an endpoint is reached. When approaching the endpoint volume, a good habit is to wash the sides of the conical flask with distilled water from a wash bottle, as when swirling, the side of the conical flask will touch the tip and some of the titrant will stick to the walls of the flask. If there is a droplet hanging on the tip of the burette, wash the droplet into the flask using a wash bottle, especially when approaching the endpoint. Washing off the titrant will result in a more accurate and precise result. Once the endpoint is reached, the final reading is taken and the total volume of titrant delivered is determined by subtracting the final reading from the initial reading. Titrations are generally done in triplicate, so you will need to perform 2 more titrations. To get precise results, your volume of titrant delivered for the 3 non-rough titrations should be 0.1 milliliter difference between each.
Everything else here is not important already. Guys, so right, if you look here, right, yes, Sarah, I understand. So if you look here, right, this here makes more sense right now, guys. First and foremost, look, this will be the this time it will be different. They are using the acid on top here, and then the alkali will be at the bottom here. Okay, but anyways, it will be almost something similar, right? So first and foremost, I'm going to use the solution. In this case here, I'm going to use the alkali, right? And I add the indicator in. And as I add the indicator in, right, because the the phenolphthalein, right, will actually turn pink in color in alkali, right? So initially, this thing is pink in color. And then once I know that this is pink in color already, right, I'm going to start slowly titrating the acid inwards. Okay, I'm going to add the titration all the way, right, until I swirl it and then suddenly it goes from pink color into colorless color. Right, as soon as it goes into pink color to colorless color, right, it's the same as the video, right? I have to record down how much was the start and how much is the end. The amount of acid in this case here I use is between these two here, right? Then once I have this, right, I have to do usually 3 times. I have to do it 3 times to get an accurate amount. Then after that, I have to repeat the whole experiment again without the indicator this time. Because with the indicator, it actually makes the liquid there's some impurities in the solution, which is not what I want. Ultimately, I want to create as pure of a salt I can by heating it up and once again letting it evaporate over time. And ultimately, once that's done already, right, I'll get the white crystals, which is the salt that I want to get at the end. To create the salt, to get the salt that I want. Yeah. Okay, the add water step there is a bit extra, which I don't think we practice in high school. Why they add the water in, right, is because they want, as I swirl this, right, imagine all the alkali, right, is stuck to the alkali or acid, is stuck to the side of the bottle. Then every time I do the titration, right, every time it will be a different result, right, because I can't control how much amount of alkali is stuck to the walls of the bottle, right? So what they did was, right, which is just an extra step. I don't think you actually do it in high school. They use the washing liquid, which is usually neutral. They wash down all of it. All the acid and all the alkali will be basically back down here. And then they will continue titrating it again. So it gives a more accurate result. But I don't think you'll use it in high school. You just need to know this though. Yes. True story. I think you should be able to play with this in school. This is like the most basic one that you have in school for chemistry. Done titration? What do you guys do in the lab then? When you've done this before, titration in school? You? Okay, guys, listen up. I'm going to stop class here today. I want you all to really, and when I say, hey, everyone, pay attention. Everyone, please pay attention. I really need you all to read through everything here. Okay, everything here until you see this part here. Don't do this because later I'll show you a YouTube video which will explain everything. This is very important because it always comes out in your exam. For sure will come out in your exam, this part here. IG lah. Read up until here. Please bring questions and ask me next week. I'll try my best to answer everything as close to the syllabus as possible. This is your homework for today. Go back and read everything. Huh? No. No homework. Okay, guys, we'll continue this next week.